Welcome to Container Orchestration on Apache Mesos. And we will talk the next 50 minutes about how you could use Apache Mesos and DCOS to orchestrate your Spring Boot applications together with your data applications like Cassandra, Spark, and all these kind of applications. And this is me. My name is Johannes. I'm working for the company Mesosphere. It's a company behind DCOS. And you can find me on the internet, on Twitter or in the DCOS community Slack channel. So we have a Slack channel, and if you have further questions, just go to chat.dcos.io and ping me to get all your questions answered. But today I want to tell you a story, the story about Alice. And Alice is a Java developer and really likes Spring Boot, but also Alice really likes Chuck Norris jokes. And besides the political activities of Chuck Norris, this is really funny. So we will have a bunch of jokes today and hopefully some fun with that. And she wants to put this application in production in 3 easy steps. So the first step is she wants to run it locally. So download SQL database, download JDK, install that, run that. And then she gets to the point where she wants to share her application with her team and her integration test environment. So she wants to put it in containers. So she put her application, the SQL database, in containers, her Spring Boot application in containers, and shared with her team to use such infrastructure products like Docker registry and so on, which are really great to share applications together with all the dependencies in one container. And the third step is to run her application on a big cluster, scaling out, scaling her joke app to 20 or 40 instances, whatever you like, or how many users you have. But this is probably the most difficult part, to scale out in production and have it reliable in the data center. But let's start with the first 2 steps. So I prepared a GitHub repository for you, and if you follow that link in the slides, I will share the slides afterwards, you come to the repository where everything is documented. So you get the abstract, German, English, where the slides are, what's inside this demo, and how you get this started. And you get the database and the Spring Boot application. So the first step probably is to have a look at the database. So it's a SQL database, and we use root user without password, and we should start the database up front. So without password, we use check database and select everything from jokes, limit 5. And we do have different languages. And first of all, we want to select English jokes. So we do have some jokes, and giraffes are born or created when Chuck Norris uppercuts a horse. So probably we do have over 4,000 jokes. And we will do MapReduce later on these jokes. So this really simple table, just having ID, joke, and a language. So it's really basic. And our Spring Boot application is also really, really basic. Let's go toggle presentation mode. Have a look at this. So I'm using Spring Boot for this, and the nice thing about Spring Boot is having nice ways of configuration to be able to configure your properties in the Java properties or via the command line arguments, but you're also able to override these kind of properties by setting environment variables. And that's what I'm doing here with the add value annotation. So I want to configure my application based on my environment. So this means check if you find the service version environment, the service version property in your properties or in your command line arguments. And if you not find that, check for the, but you can also override it by environment variables. And if you don't find it anywhere, just use the default 1. So in this example, we are going from service version 1 for local development to 2 for running in Docker, and then 3 and 4 for running in DCOS. So if I'm not providing any configuration, the 1 is taken. And the same is true for MySQL URI. So I admit this is probably the worst way to configure a database connection, having 1 string including everything, user, password, and database. And I also set a time zone, but it's a different story. So the same is true for here. So if I'm starting from Spring Boot, I'm using localhost 3306 and database check, user root, no password. But when I later on configure it via environment parameters, I'm able to connect to my production database, right? But we do have more properties in this service. So later when we are scaling up our service, I want to show you that different applications are answering. So we do have the node ID property, which is basically a UUID. So when we're scaling to 20 instances, I want to show that different applications are responding and that these services are really load balanced. Same is for host address, so that we're showing that there are different applications answering from my local box in Docker Compose and later DCOS. And I have the Boolean healthy. So what I'm doing, we're introducing health checks, which are pinged every 2 or 5 seconds. And if the service is responding with a 200 HTTP code, this is a good sign, and so DCOS will think this everything okay. But if you're not responding with a 200, DCOS will have a look for certain amounts of failures and then replace it with a healthy one, or hopefully healthy one. So this is configuration for a service. And then the most funny part is the root request. So if you do a get on root, so we're checking if we have accepted languages, and if we have accepted languages, we're just getting a random joke from the database. It's done via plain JDBC, so nothing fancy about that. And we're setting this to the response, saying some meta information, host address, local node ID, and the version, and also the joke. And for 2 health endpoints, we do have a get on health. This decides if the service is healthy, then you get a proper result showing JSON that everything is okay. But if it's not healthy, you get a 500 runtime exception. But if you do HTTP delete on this endpoint, this Boolean is toggled to false, and then you get these kind of 500 errors. So let's start this service. We quit MySQL, go to our folder where our POM lives, and say maven spring boot run. Probably make it a little bit bigger. See our Spring Boot logo, and it's booted. If we now go to localhost 8080, we see random Chuck Norris jokes. Oh, probably want to see English ones. I'm sorry. Oops. Okay, so we do have German jokes, but we do have English jokes as well. Maybe a short one. Chuck Norris is so fat he can look at raw with the keys. Okay, forget about that. So what I want to show you, you get a proper response with your host address of my MacBook, with a local English, this UUID, and the version 1. So, okay, works in my machine, check. But now we want to have Docker images to share a replication, to pack all together in this image and upload it to Docker registry. And for this purpose, I prepared 2 Docker files. So if we go to database folder and to the Docker file here, you see that I'm starting from MySQL, a root container, a root image, configuring that I now use a proper, more or less proper password. So the user is Chuck and the password is Norris. And I'm adding this initialized SQL file. And this image is built that if the MySQL image finds a SQL file in this particular Docker entry point folder, it will be applied on the boot. And this initialized SQL is exactly what we saw. We saw the create table, where ID, joke, and language, and our insert into. So I'm inserting 4,500 jokes and some German jokes as well. So this is the database service, database image. And for the Java image, it's probably more easy. So I'm starting from Java 8, adding my Java file to app.jar, and saying I want to start Java.jar app.jar. So it's really easy, this container. But to start both containers together, we're using Docker Compose. So Docker Compose, for those who not know, as a tool to start multiple containers at once and to gather them together and having a proper DNS name, etc. host entries for all the containers defined. So when we now define our database container, it's the image we saw the Docker file before. This database host name gets injected to etc hosts of the other containers. So when we start then the service, the Java service container, we can configure our database to connect to hostname database on port 3306 with the password and the username we defined in the Docker image. So, but let's start at the beginning. So our Java service using the Chuck Norris Java service image, exposing port 8080, and it's depending on the database. So that means that the Java service starts when the database is started successfully and responding. And we configure environment variables. Like I said, we do have the MySQL URI saying I want to do JDBC MySQL database 3306 with Chuck Norris and password Norris, and the service version 2 now. And we then go to the folder where this Docker Compose file lives, this one. We can just say Docker Compose up, and then we see first that the database is starting, so we should see kind of blue line logs with the database logs, and after that, after the database started, we should see the Spring Boot booting logo and then Spring Boot starting. But obviously this is not working. Host is down. Oh, that's... I think I restarted my laptop recently before the presentation. I forgot to start Docker machine again. I'm sorry. So this should be fixed in a second. Oh yes, so now we can continue. So we see the database logs, and as soon as the database says, oh, I'm up and running, the Spring Boot application is starting, we see all the Spring Boot logs we saw in the local development as well. And we now go to the IP. So I have a symlink from local doc to my Docker IP. Then we see that the host address changed. So it's now the bridge network of Docker showing in the host address. And we do have another UUID, like we saw here on the other machine. And we do have service version 2. And if we're doing reloads, we get random Chuck Norris jokes. Chuck Norris gave the Terminators emotion fear. Okay. So that's really funny. Okay. So, okay, go back to one step back. So back to the presentation. So we saw works on my machine, that works. Run everything in containers, that works as well if you start Docker machine. But now, what about production? So when I now stop Docker machine or when I stop Docker Compose, it's a command that runs on my shell, and if I do Control C, it's stopped. It's probably not what you want to have when you run a production, hopefully. So, well, let's one step back. So what we currently have, we do have our infrastructure, it either virtual or on bare metal. You have installed your operation system on top, and on top of your operation system you have your container runtime. And on top of the container runtime you have your services and applications and everything exposed to the web and so on and so on. So this is really great because you can utilize your resources, your machines, really good when starting multiple containers independently on one box. But what is missing, and what we saw at Twitter at the time, we'll talk about Twitter a little bit later, they did so-called spreadsheet scheduling. So what they did, they had the requirements to run certain application 1,000 times. But when you do it everything manually, you're probably really busy with taking care that everything runs in the expected way. So what they did, on every Friday, they sit together, the ops team, and had a spreadsheet showing, I need 1,000 instances, I have 900 running currently, so probably I need to figure out some space to run the missing 100 that got lost over the week. So this kind of manual work is not the best way to run productions. Because when talking about production, we should talk about container scheduling. So where to place my container, where to start my containers, what should happen when we scale up or when we scale down, and what should happen when we do an upgrade, so in version 3 to 4 or 5 to 6, something like that. And we should care about resource management, so limiting containers to a given amount of CPU usage, to be not able to one container to take down the whole system, or memory reduction, memory limits, something like this. And we need to talk about service management, like that our ships travel to the right direction. So service discovery, that your services can talk to each other, and health checking, and dependencies between applications, all these kind of stuff. And when we talk about scheduling, resource management, and service management, we talk about container orchestration. But honestly, we're not talking about ships. So ships are really great for presentation, but actually we're talking about this. So we're talking about placing your containers. Maybe you have placement constraints. You say, oh, this kind of application are only allowed to start on nodes with specific criteria, like having GPU support, something like this. And maybe you have requirements to have a special replacement strategy. So when one container fails, you want to restart the replacement task not instantly, because you want to wait a few seconds or few minutes. Imagine you have a Cassandra node carrying 20, 40, 60 gigabyte of data. You don't want to do a full replication instantly. You probably want to wait a couple of time to see if the container comes back or not. And same is true for resource management. So you want to limit your container for CPU, memory, and disk. And probably you want to say what kind of IP or ports your container can consume. And for service management, like I said, you probably want to have load balancing. We see load balancing in a couple of minutes. Service discovery, like finding other services, and health checks, checking if my services are up and healthy. So our architecture looks now a little bit like this. So we do have a container runtime. On top, we do have resource management, scheduling, and service management. On top of that orchestration layer, we do have our web apps and services to have a fully automated production environment. And this is the point where we want to talk about modern data centers. Because I did Java enterprise development before, and what I saw often was something like this. So you have a big cluster, 40, 50 nodes, something like this, but you do static partitioning. So you say upfront which nodes should handle which kind of application. So in this example, you have 10 nodes for Hadoop, maybe 15 for database, 30 for your Java services, and Spark and Memcache, something like this. But you say upfront which node does what application. But in case of failure, so imagine your Java services, 20% of your nodes fails. But on the other hand, you're having a load peak. So you're having real customers want to buy something from you, and the Hadoop part is idling because you only do MapReduce in the evening or in the nights. So this is really bad for you because you cannot dynamically shift your applications to other nodes. Or the other way around, you want to have a high utilization to save nodes. Well, you often have something like this, a usage over time, over the day. So you have your Java services basically all day with a low utilization and a peak in the evenings when everyone comes back from work and want to shop. And your Spark is running all day, but Hadoop is only running in the nighttime. And this is really bad utilization, so you're wasting a lot of resources, CPU, memory, and disk, and so on. You probably want to have something like this, to run everything on one resource pool, on one cluster, and share resources dynamically. Because you want to have something like this. So you want to have we see the old world having static partitioning, but you want to mix that. You want to shuffle around and be able to dynamically start and stop every part of your application, database, big data, fast data streaming stuff together with microservice, and you actually don't care where to start as long as everything's running. And this is the point where Apache Mesos comes into the game. So Apache Mesos was invented in 2009 at UC Berkeley, and there was 3 students doing a PhD about fine-grained resource sharing in a cluster. And this was exactly the time where Twitter had these crazy scaling problems. You remember the Twitter fail whale? So these sad whale crying and not responding. So that was exactly that time. And these 3 students gave a tech talk at Twitter introducing their paper. And Twitter was kind of amazed by this concept of resource sharing. So having a system carrying resources and sharing to the cluster to different kind of applications. And so they were really amazed and pushed it really forward. So in the same year, there was a source code draft published, and the same year, they entered Apache Incubator project. And now Twitter runs on really big installations. So Mesos runs on really big installations. So one of the biggest ones is Twitter. So Twitter.com has, I think, 27,000 nodes to run Twitter.com. Airbnb runs Mesos, but also Netflix and Apple. So Apple also published their numbers 2 years ago, I believe, and they're running Apple Siri on Mesos. And this is a really great example. So Apple is able to shift the workload for every particular language up and down based on if the users are awake or not. So if we're in Germany online and awake, they are scaling up the German application. I may be scaling down some US instances because they're sleeping, and the other way around. So, and the Spanish one, probably the same time zone like the Germans. So this is a great example how to maximize your cluster utilization, or on the other hand, minimize your cluster nodes to have to cover the same workload. And Mesos works basically this way. So you have 2 kinds of Mesos nodes: Mesos master nodes, which are management nodes having an overview about the cluster, and you are able to have these high available. And you have Mesos agents. And Mesos agents are executing nodes, executing Docker containers or Mesos containers. And if you are a Mesos agent, you say to master, hey, Mesos master, I want to share 4 CPUs and 60 GB of memory with a cluster. And the Mesos master would say, oh, okay, you want to share these resources, I'm asking registered schedulers. And on the other hand, you have a couple of predefined schedulers. So we do have the Marathon scheduler, which is a Mesos scheduler for container operations. But you can also have a Cassandra scheduler for operating Cassandra on top of that, or Spark, or Kafka, or ArangoDB, or something like this. And the actually scheduling decision is done by the scheduler. So Mesos master would ask Marathon, hey Marathon, do you want to start some containers on top of these offer? And then Marathon had a given amount of time to decide if and how many schedulers should be launched on these 4 CPUs and 16 GB of memories. Or beside that, you have a myriad scheduler, which is basically a bridge for running Yarn, so Hadoop on top of Mesos. And if Marathon declines this offer and say, oh, I don't want to launch anything currently, this offer is passed to the next scheduler. And maybe a Hadoop job is started, or Cassandra node is started, and so on and so on. So what we have is a 2-level scheduling. So I, as a user, I'm talking to the scheduler and saying, hey, Marathon, I want to start my Chuck Norris service 20 times. Please take care that this happens. And I have these resource requirements. Each container should have 1 CPU and 2 GB of memory and so on. And Marathon, on the other hand, will talk to Mesos and make sure that these containers are started on these given offers. And the decision that this is separated, so resource management on the Mesos side and scheduling decision on the scheduler side, was made on purpose, because scheduling stateless containers is really, in comparison, is quite easy, because in terms of failure, you can just restart it somewhere else and don't need to take care of data. But when you're scheduling a Cassandra or Kafka cluster, this is a little bit more complicated because you're dealing with persistent data, so you probably want to keep that data if the task is lost or do an upgrade. So you need to do more business logic to your scheduler saying, oh, when this node fails, I want to wait some time, and if it comes back, it's great. I don't need to do replication, but when it's not coming back, then I need to restart somewhere else and do the replication. And when we talk about Cassandra or Kafka, we should talk about all the data options you have in your current application. So probably, mostly, there are three kinds of applications currently running around. So you do have stateless applications, so like Nginx or a Tomcat or a Spring Boot application. And you get a simple sandbox for these kind of tasks. So you get a space and a folder where you can put your files on, but when the container is stopped, this sandbox gets deleted after 5 minutes or something like this. But when you have a database which is written for distributed systems, so a scale-out database, and these kind of databases are scaling by adding more nodes, like MongoDB, Couchbase, Cassandra, or Elasticsearch, you want to be able to reuse your data. And in this case, you can use local persistent volumes, and this works like a label for your disk space. So when you configure this, you get a reserved place on the disk, and when you're doing an upgrade, so you're stopping the container, starting the new version, you're able to launch the replacement or the new task on the exact same data again. And this is quite helpful. So we're not doing fully replication because we can start on the same data again, and Elasticsearch can, for example, can decide on its own if Elasticsearch wants to reuse the data or if it's too old and Elasticsearch wants to do a replication on that. So these are first two parts, but we also have traditional databases. So I'm meaning not the clustered version of MySQL or PostgreSQL, for example, so the really single instance versions of that. And in this scenario, sure, you can make backups. And you should do backups for these kind of databases. But when you're running an operation, a production system, you probably want to be more flexible to have a failover strategy, to be not in the situation to apply your backups. Instead, you could use external volumes, like writing into a distributed file system, an NFS, something like this. So when the task fails, you just can restart a new MySQL instance pointing to this network device and just be instantly able to run your production further. Sure, you have downsides on that, so you have distributed writes, which are really expensive, but you're able to get these kind of traditional databases in a more fault-tolerant way. And this is, so we do have everything together. So we do have microservices, so container orchestration together, we have data together. I want to talk about DCOS. So DCOS is a platform to run your microservices together with your big data applications and your streaming applications, your machine learning stuff, your NoSQL time series databases, all together on the same resources. And on top you get a security concept, you get a CLI, you get a UI, and a bunch of docs. And the best thing is it's totally open source. So DCOS is more or less a package of roughly 30 open source projects packed together to one distribution with a common roadmap, design, and tutorials, and one installation guideline how to get this working. So we do have CloudFormation templates, installation for Azure Cloud, Google Cloud, and on-premise installation, so everything is in place. And now I want to show it by the Chuck Norris. So scaling DCOS with Chuck Norris. And for this purpose, we have a look at the DCOS dashboard. So when you enter DCOS and you're authorized and logged in, you see this. You see an aggregated view on your cluster resources. This is probably what you want to see when you get a call at 3 a.m. that something is wrong with your application. So you see aggregated view, how many CPUs are free in your cluster, and how many memory is free in your cluster, and how many disk is free, and about your service health. So are all containers are healthy and how many containers are running and how do you have unhealthy running containers. And the fact that we're dealing with a distributed system and that we have 7 nodes, 7 Mesos agents in these clusters, just a detail you care about when the other numbers are bad. So going back to this navigation, we go to services, and behind this service section, this is everything around Marathon, so container orchestration. And you can really easily start an application with this UI. You can say I want to use a single container application or a multi-container, co-located application, what's called pods. And you can define a name for your application. We're doing sleepy now, so just doing bash command sleep 100 seconds. And you can decide if you're running this on Mesos, on DCOS, you can decide if you want to have a Docker engine behind. So if you want to run this command in a specific Docker image, or if you want to use Mesos runtime. And Mesos runtime is an on-the-fly container wraparound doing C groups and namespaces around your bash command. And you can also say, I want to run my beloved Docker image directly on top of Mesos without Docker engine, if you want to. But we're using Mesos runtime now because we just want to do a sleepy application. And what we then see is that we're sleepy. We do have information about this one running task, on which node this is installed, which files are in the sandbox, and what kind of logs we produced. And this is not producing any logs. But we can scale this application really easily. So we can say, I want to do 10 sleepy applications, so distributed sleep. So we can scale this really easily. We can also, in this kind of generic scheduler, we can add more fancy configuration. Like we can say, I want to use specific networkings, I want to have specific volumes, I want to have health checks defined, or environment variables defined. And I can also say I have placement constraints. So please don't always place only one container on a node, so a hostname uniqueness constraint, or scale everything on one node, or scale it evenly across your cluster. You can define such things in these kind of configurations. And you have the same thing for jobs, for scheduled containers. So imagine a cleanup job on your cluster, or some batch processing, which are only executed in the night times. And the next thing is the universe. And the universe is our kind of interpretation of an app store. So you can install a Cassandra cluster just by 2 clicks, or a Kafka cluster or Elasticsearch cluster just by 2 clicks. And we want now to install Marathon LB. And Marathon LB is a HA proxy, which are automatically configured by the deployed application in Marathon. So this load balancer is configured by the running containers automatically if you add some meta information on this. And we want to install Zeppelin. And Zeppelin is a web notepad to enter Scala code. And this Scala code is afterwards compiled to JVM bytecode. And then this bytecode runs a MapReduce against a proper Spark cluster. So we're doing in-memory MapReduce by entering source code to our web browser. It's kind of cool. Okay, so while these 2 applications getting deployed, I want to go back to Chuck Norris. And in Chuck Norris, we do have these Marathon configuration for Spring I/O. And I can have my CLI DCOS Marathon. I want to add a group of applications, my database and my Java service. Group add posting this JSON file. And when this gets deployed now, I want to show you the content of this JSON file. So it's kind of similar to the Docker Compose file, but more text because we can configure more. So our group of application has a name, Chuck Jokes. And the first one has a name service, so for a Java service. And it has a dependency to the database. It has the same semantics like in Docker Compose, to just start the service application when the database is running. And we do have resource requirements, a quarter CPU, 1 GB of memory, and 2 instances. And we have health checks configured. So this meaning the health endpoint is pinged every 2 seconds. And if we do have more than 10 failures in a row, DCOS will take care to stop this unhealthy container and replace it with another one. And we do have a container configured. So exactly the same container we use for Docker Compose for this MacBook, we use now in production, but just with another configuration. So we're using a bridge network, and we're saying, I want to have a random host port. I don't care about the host port. Marathon LB will take care that this is wired to the correct endpoint afterwards. But I want to expose port 8080 on that one. So this is all around the container stuff. And again, we do have our 2 configurations, MySQL URI and service version URI. And now I'm using this kind of string. I'm using database.marathon.l4lb.dcos.directory with the known username and password. And this is a DNS entry pointing to the database host. This is also load balanced, so MySQL is not able to be scaled behind a load balancer, but if it would be, you could scale the database behind the load balancer as well. So this is kind of service discovery mechanism. And we do have service version 3. And we're defining that the HA proxy is able to recognize this Marathon application with entering our domain name, which is exposed afterwards. And the database is configured basically the same way, having an ID, naming database, resource requirements, Docker container, again, the exact same Docker container we used on Docker Compose. And then we do have the port mappings, exposing our database port, having the database symbolic name. But I could also define a virtual IP saying, I want to have this particular port and this particular virtual IP exposed to my cluster, and everything happens on this IP should be routed to this container. And we do have health checks as well. And if we now go back to our Marathon dashboard, we see that everything is up and running. And when we now go to the URL we configured, in the configuration we see that Chuck Norris uses boxing gloves instead of... Okay, forget about that. So we're doing some reloads to get see that this is really load balanced, but there are only 2 instances running. So what we now want to do is scale up, and using CLI DCOS Marathon app update, check joke service, I want to say instances equal 20. So we want to change the property instances to 20. And what happens then is that we see a deployment. So currently 8 of 20 applications are running. And if we then go a little bit deeper in the UI, we see that 2 are healthy, so 2 passing the health checks. And 8 are currently unhealthy, so the container is started, but the health checks are not passed, basically because Spring Boot does not have started the software container yet. And the others are in staging, so it is known where this container should be stored, but probably the Docker images are currently pulled. So, but I think 8 are enough to show you that this is load balanced, so we do see other host address answering us, so 2 and 3 and 6. So Chuck Norris invented the yellow brick road. Okay, so this is really load balanced. And what we see when we go inside one of the healthy ones is that we do see the proper log files on that. You could use log files for CLI as well, so you could gather these logs or pipe it through a centralized logging architecture like Elasticsearch with the ELK stack, something like this. So this is really, really useful. Oh no, I want to go to service. But now we want to kill them again. So I said we do have the delete endpoint, and when I do curl-x delete on health, some of them should be, this is a previous version. I need to do a put, I'm sorry. So Oh. So, it's a small. It's HTTP. You're right. Thank you very much. So, now we have the right HTTP word and the right URI. I entered 3 times the curl with the delete call, and now we see that 3 are unhealthy. So we now go to the log section. We see that we see a runtime exception, the meh exception. And when we go back to our overview, we saw that, oh, probably they're all healthy again. So let's toggle the health of one more. So when we now go to the one unhealthy one, this one, Marathon will do 10 times in a row the health check, and if it's 10 times not responding with a 200, Marathon will stop this one and restart it somewhere else in the cluster, and hopefully the new one getting healthy afterwards. So this to that topic. Okay, so now we do have seen that we can scale it. We have failure handling, and now we want to do a short walkthrough and upgrade. So imagine you want to change your version of your Docker container, or you want to change environment variables on your container. You can just say, I want to change service version from 3 to 5, or application version from 3 to 5. In this context, it's just a meta information we display, so the deployment is probably really trivial, but you can also configure more complex deployments. And the default behavior in Marathon is a rolling upgrade. So you can configure that how many nodes you want to start from the new ones, and how many from the old ones should be stopped afterwards. So we do have a rolling upgrade by default, starting 3 new ones, stopping 3 old ones. So this rolling mechanism. And when we then go to our endpoint, we see that service version 4 is responding, and service version 3 should respond sometimes as well. So really have a rolling upgrade. You could also use traditional blue-green deployments if you want to, or kind of Canarian upgrades, like starting 10% of the new nodes, piping 5% of the traffic to the new ones. And if you get confident with the new version, then you can say, I want to scale up the new version to 50%, 70 or 100%, and route more traffic to the new application versions. Okay, so we do have a version upgrade to service version 4. And now we want to integrate our application with a new and shiny fast data and big data world. And for that purpose, we're using a really, really trivial Spark example with Zeppelin. So Zeppelin is the web browser where you can enter your Scala code, and it gets compiled to bytecode, and then afterwards it gets executed on the Spark cluster. And the great thing is you can store your Scala code as JSON. So your workbooks, your notebooks, you can store it as JSON objects. And all these Zeppelin jobs contains of 3 steps. So loading dependencies, do the analysis, and display the result. So I'm using the MySQL database connector, so JDBC connection. And if you're pressing this tiny little play button on the top right end, this gets compiled currently and then entered to the JVM. This takes a while, so it took 7 seconds. And I will compile the other one as well. So what we're doing here, we're connecting to the database, now using the virtual IP service discovery mechanism, going to IP 3306 and port 3306. And we're doing JDBC select everything from jokes where language English between 1 and 5,000, and just go out and have the joke property of this. And then we do MapReduce having a word count. So like the most trivial example for MapReduce is splitting the whole jokes up by white space and then making tuples out of it to word and one in the map phase. And you can highly distribute this step because you can say one node do jokes 1 to 1,000, the second node 1,000 to 2,000, and so on. And then the reduce step you do for each same keys on the tuples, you summarize the values, and you can highly distribute that. And then we can run this. Oh, probably out. Oh, it's updated. Okay, so good for me that the results are cached. So the result set of that you can query with a SQL-like language as well. You can say select word and count from word count, order by count, descending limit 20. So you give me the 20 most frequent words in the Chuck Norris joke example. And the most frequent word is obviously Chuck. And the second one is Norris. So we do have 4,425 Chuck Norris jokes. And Norris is a little bit less. Then we do have with, then, when, once, roundhouse. So 226 occurrences of roundhouse in all the 4,500 jokes. And then because on your doesn't have kick. So 160 occurrences of kick. And the funny thing is that you do have 150 occurrences of face. So this is probably related in your data set that kick and face is the same occurrences. Okay, so go back to presentation because I think we're running out of time. So yeah, that's it. Hope you had fun with the Chuck Norris jokes and the rest of the talk. And do you have questions? No questions? Everyone okay?
So regarding the networking across the containers, so
yeah.
Is this some kind of overlay network? And how is DCOS provide this, or we should install something on top?
Yeah, so the question was around networking. So basically, in DCOS, you have three kind of network options you can choose. You can say my container should join the host network. You can say my container should use a bridged network, and then you have a bridge network configuration, and then you can say how the port mapping should look like. Or you could use an overlay network, and DCOS also provides the overlay network, so you're not able to use fancy Docker networking stuff. So we're relying on CNI networking, and you can say this container should join this overlay network, and in this case, every container gets an own IP and exposing all ports. So you have a real overlay network and, again, special ways of service discovery for these kind of overlay network tasks. Thank you. That's it. Great. If you have further questions, I'm here for a couple of minutes. I do have some information materials and stickers if you want to. So have a nice conference and enjoy the beautiful weather here in Barcelona.